As an engineer, anything is possible. Engineers create and they provide solutions to real-world problems. At QUT, your engineering degree is all about the real world. So now let's hear what it's like to study civil engineering.
Hi, I'm Danny and I study civil engineering at QUT. Civil engineering is the design, plan, construction and operation of many different infrastructure aspects of our society. So from roads, bridges, tunnels, underground pipe networks and large high-rise construction and design. I chose to study civil engineering because it has a lot of elements of creativity involved in the structural design process, and so I'd like to express my creativity through structural design. So my first year in civil engineering involved with many common units, so that really helped me out because I wasn't sure what major I wanted to go into. So I got a taste of mechanical engineering, electrical engineering and everything in between, and that sort of really made it clear as to what I would do later on. So my second year of civil engineering involved a lot more specific civil engineering subjects. So that involved the actual design and construction of a small portal frame, and that was a really good experience to design something and then actually test it to its physical limits. My third year began with me completing a 6-month exchange in Germany, in which I was part of an internship program with Hochtief and got to study in Germany while the World Cup was on, which was an awesome experience. So my internship in Germany as part of my QUT exchange semester allowed me to be a part of a large-scale project in Saudi Arabia for a new city design for 200,000 inhabitants. That was a really large-scale opportunity with lots of different aspects coming from all over the world, designs with international partners, and I was really excited to be a part of that opportunity. So in my second year of civil engineering, I was part of a large university project in which we had to design a new eco-friendly residential facility. This designed actually going out to an existing facility in Coomera and observing the different techniques of design on an existing structure and bringing that back into the university setting and putting that together in a formal report. So my work integrated learning or WIL experience began with my internship overseas in Germany and ended with my working here in Australia for a large engineering construction company, McConnell Dow. Through them I've been working for large rail projects with a tendering team trying to win the work for the company to then go out and build. So I've learnt many different aspects of construction management and also civil design.
60-second subjects from Newcastle University. Civil engineering. Civil engineers design, build and maintain the infrastructure that underpins our lives. The course is design intensive, giving you the chance to study infrastructure, modelling and informatics, environmental systems, human management systems and surveying. You'll also get the chance to specialise in the aspects of civil engineering that interest you the most. An engineering degree will give you the skills for a career in a wide variety of areas, such as management, administration, banking, insurance or teaching. Most of our graduates go on to work for industry leaders such as Arup, Atkins, AECOM and Laing O'Rourke. You can even get involved with overseas meetings and conferences, field visits to live civil engineering sites and networking opportunities. You'll be assessed through written and computer exams, reports, presentations, portfolios and other coursework. The course is taught through a mixture of lectures, practical work, site visits, individual study and group work. Newcastle University are in the UK's top 10 for civil engineering, and our courses are accredited by professional bodies giving you industry-wide recognition. And that's civil engineering at Newcastle University in 60 seconds. To find out more about this degree and others at Newcastle University, visit ncl.ac.uk/undergraduate.
Around 75% of lives lost in all earthquakes are due to the collapse of inadequately designed buildings. In order to design earthquake-resilient buildings, let's examine the cause and effects of earthquakes. Tectonic plates are part of Earth's crust, constantly moving due to convection currents in Earth's mantle. When two plates rub against each other, pressure builds up due to friction. However, when the strained crust eventually overcomes the friction, an earthquake is triggered, sending out compressive waves with push-pull effects and shearing waves with sideway displacing effects. These seismic waves are vibrations related to earthquakes and are of varying frequencies. Taller buildings experience more impacts from low-frequency waves, Waves of different frequencies affect buildings. If a shock wave matches the natural frequency of a building, the building undergoes the largest oscillations possible and suffers the greatest damage. To diminish the destructive energy induced by earthquakes, civil engineers use different types of technologies. Base isolation dampers are reinforced rubber slabs that sway left and right to isolate the building from shock waves. A viscous damper absorbs and dissipates the energy of shock waves that penetrate the building. Like a pendulum, a tuned damper reduces vibrations by counteracting the extraneous vibrations with its mass. Seismic invisibility cloak is a set of plastic rings buried beneath ground that steers the incoming seismic waves around the building foundations. These four are some of the methods that safeguard lives. In 2010, 316,000 people were killed by an earthquake in Haiti. However, a quake of similar magnitude in USA killed just one person. Why? Because of earthquake-resilient buildings.
Let me start by giving an overview of civil engineering as a discipline. Civil engineers are obviously involved in construction, in the design of buildings, and also overseeing the construction process. There's many other aspects to civil engineering. For example, civil engineers need to have an understanding of geotechnics, so how structures interact with the ground. They're involved in transport infrastructure, so road design, rail design, surveying, which positions roads, rails, buildings, and so on. There's aspects of hydraulics within civil engineering, which look at fluid flow, things like flood alleviation, and also management. There's management processes involved in all of civil engineering aspects I've just mentioned. All our courses are accredited by our joint board of moderators, which means pathways to chartership are clearly defined. So there are many unique aspects to civil engineering courses at Coventry University. First of all, our courses are very practical. Quite a lot of lab activities and surveying practicals embedded throughout our course. For example, our first year students would have typically 18 hours worth of labs or practical activities. We have the UK's only construction site simulation centre, and we embed this in part of our management modules within civil engineering. So this looks at putting students in a virtual construction site environment and testing them on their management skills with certain scenarios. The university has very strong links with various civil engineering companies, a range of consultancies, and also civil engineering contractors, local authorities, and so on. And this enables us to organise events where students can network with potential employers. We have relevant field trips within our course, and we also regularly organise site visits to allow students to experience hands-on construction processes. There's a big emphasis on employability skills within our courses, and this is largely facilitated by academic personal tutors, which look after a small number of students. We have placement opportunities within our courses, and those placements are organised by our EC Futures team, who won the award for the best placement service within the UK just recently.